So we want to look now at just general straight lines. So remember that when we had a proportional relationship, okay, so proportional relationship, what we had was just that we could write something like y equal mx. When we did that, we always got a line that went through the origin. So this is y equals mx. And then in the case of an actual proportional relationship, m was always positive, but generally we could, we saw that we could also have, well, actually I'll put it back up here. We could also have, for our x and y, we could have an m that was negative and have a negative slope like that, y equals mx. So over here, m is greater than 0, and here m is less than 0. And so I don't know that I would really call this a proportional relationship over here on the right, but it's that same idea. We just have y equals a constant times x. So the algebra is that we see y equals a constant times x. Okay, so again, y equals a constant times x. That's our algebra, our algebraic language. Then graphically, what we see is some sort of line through the origin, line through origin, and this is our graph or graphical language. And then remember that, whoops, don't want that. Then we still had tabular as well, where, if I see something like, well, we'll make it simple, like 1, 2, 3, and then y is a multiple of each of these. So, maybe this is 5, then 10, then 15. So we see y is just 5 times x. Well, then this is a table or tabular language. But all of those represent this same idea. And so you see we've got these 3 languages all to represent either, if we want to picture in our mind, a line through the origin, or really the algebra and the table, I think both lend themselves to talking about that y is some constant multiple of x. Definitely this algebra says it. I mean, there's y equals some constant times x, but the table, we have to look at the numbers and think about it a little bit. We can see that, yeah, y is just 5 times 1, and then 5 times 2, and then 5 times 3, and so that's the language that we already have. Now what we want to do, and we'll start with what we call the slope-intercept form. And the reason I want to start with this form is, well, one, probably most of us are most familiar with this, where we have an algebra here, but then we could also have a picture. And now notice the difference in the picture is that height there is b, and then of course the slope is still equal to m. So what we've done is we've raised or lowered, because if b is a negative number, we would lower a line through the origin. So if I start with y equal mx, you see what would happen is if I think of coordinate pairs, so I have all these points along a given line, well, and I would have points that satisfy this relationship. So if I have something like this, let's actually make it, like y equals 3x, then notice that, and I'll use some nice numbers here. We get 1 and 3, so if x is 1, y is 3. So this is much like the table. 2 and 6, 3 and 9, and so forth. Now notice what happens if I do y equals 3x plus 2. Well, if I use those same x values, 1, now notice what happens. I take 3 times 1, I get 3, but then I add 2 to it. Now I'm going to actually write it this way, 3 plus 2, and that's 1 and 5. Then, if I take 2, again, that was 3 times 2 is 6, and then I add 2 to it, so I end up with 2 and 8. And then 3, and when I take 3 times 3, I get 9. Plus 2 is 3 and 11. So you see what happened, and we can think about this in the graph, is we started with this picture, y equals 3x, and then by putting that plus 2 or plus b on there, what we did was for each x value we added 2, and so you can think of it, and this is a great way to start thinking about how the algebra and the graphs go together, is I had y equals 3x, which is a line through the origin, and then for every y, since this is how I get y, so there was my part that did a line through the origin up here, and then I added that to every y value. So adding that just shifts everything up like this. There's y equals 3x plus 2, and there's a 2. That's on the y-axis, so x and y. And so we can kind of see from the slope-intercept form graphically what just happened. We can take that algebra, we can think of the line through the origin. Oh, we know how to do that. So there's our line through the origin, but now with that intercept, oh, we just add 2. Okay, and so we just shift it up by 2. So there's a quick introduction to the slope-intercept form. We'll do a little more with that, but we'll stop this video here.